Hi guys, this is Math 116. I should write that. Math 116, we are looking at section, draw a metal pen, make it white. Section 4.3. So section 4.3 is the simplex method. And the simplex method, I think, should be called the, and you thought the Gauss-Jordan method was hard method, but that's probably too long for most people. So in this particular video, I'm going to show you how to set up the simplex method and then how to finally solve it if you can get your matrix in the right form. And it is a bit challenging. So one thing to keep in mind, on page 285, that's a page, there's a nice procedural box that shows you how to go through all of the steps of the simplex method. So the simplex method, we are doing more of these problems with linear constraints, similar to what we were doing in section 4.2. But in 4.2, we were using a graph to solve it. So here's an example of what we are trying to do with the simplex method. This is question number 5. It says maximize this function f equal to 2x plus 5y plus 2z, as in z, subject to, there's always a subject to, and anytime you see these subject to's, you know you're in for a simplex method. 2x plus 7y plus 9z is less than or equal to 100. 6x plus 5y plus z is less than or equal to 145. And then finally our last equation is x plus 2y plus 7z is less than or equal to 90. So because there are these less than or equal to, we cannot use the chapter 3 Gauss-Jordan method. So we have to use another method. And it actually is easier than the graphing method, especially if you're a computer. So there you go. The main reason to do these is to use fancy computer programs to help you. But we're going to learn how to do a basic one by hand, and that is my expectation. So you have 3 inequalities. The first thing you want to do is set up what they call the augmented matrix. So the thing to notice is you have these 3 inequalities, so that means we're going to have 3 slack variables. What is a slack variable? Well, it's an extra variable to take up the slack, because we have this less than or equal to, so that could mean a lot of things. So we're just going to use 3 slack variables, and for the most part you can just think, fine, inequality, get 3 slack variables. So we're going to set up a matrix. I'm going to set up the matrix here. The first column is x, the second column is y, then we have z, then we have slack variable 1, slack variable 2, slack variable 3, then our function. In this case it's f. A lot of times you'll use z for the function, but we could use f, or maybe I'll call it w. And then you draw this line, and then the constant is going to go over here. These are the columns that you set up. Now we're going to do the rows. The first row is the coefficient of the first inequality. So it's 2 times x, 7 times y, so 2, 7, 9. Like this. I'll make it yellow. 2, 7, 9. And then slack variable 1 goes with the first inequality, and then you have 0, 0, 0, and all of that was less than or equal to 100, so you put 100 over here. Okay, next row is going to be 6, because that's the coefficient of x. You look at x, y, and z, so that's 6, 5, 1. Put over here, 6, 5, 1, and this is the second inequality, so it gets a 1 for slack variable 1. And that was less than or equal to 145. Do you see the pattern? So the first step I want you to be able to do is set up this augmented matrix. The third row is 1 times x, 2y, so 1, 2, 7. 1, 2, 7. The slack variable 3 goes with the third row, and we were less than or equal to 90. You think, well, we're done. That was all the equations we had. So then draw this line. Whoa! It's hard to draw on this little writing pad. The very last row goes with this equation. So the equation that you are given that you're supposed to maximize. Think about writing this equation. If this was w, often we use z here, so I'll write w instead of f. And we wanted to write this all in terms of 0. We're going to leave the w on this side and move everything else over to the other side. So that's negative 2x minus 5y minus 2z plus w equals 0. So if I said, well, this function represents our last variable, I'll call it w, and then move everything over to the other side to equals 0, because we're trying to solve for it, essentially. So we have minus 2x minus 5y minus 2z plus w equals 0. Over here, I have minus 2 minus 5 minus 2z, and then there's no slack variables for this one, but the w gets a 1, and it all equals 0. Whew, what have I done? I've made this complicated matrix. So this first step here, taking all those coefficients and writing it like this, is what they mean when they say write as the augmented matrix. So the first step for these problems is going to be to write it in terms of the augmented matrix. And then the second and third steps is going to be all these things that we do as part of the simplex method to manipulate this matrix. And our goal in manipulating it is to get it to look something more like this. Here's question number 9. It says, it gives us a matrix that someone who has written, is it 9? No, 19. 19. Sorry. 19 gives you a final matrix that looks like this. 1, 0, 3/4. I'm giving you the end game. Suppose you could skip ahead through all the nasty business of working on this matrix and you ended up with something. This is would be a totally separate problem that looks like this, because you'll notice I have a different number of rows and columns. So obviously it's not the same. I don't know what you people are thinking. 9. I'm copying question 19. I'm tipping my head upside down so I can read the book. 0, 0, 2, 4, 1, and 20. Suppose you had your matrix and you worked and worked and you finally got it to this stage. You think, why would I work to get it to this stage? This is no better. But it is better, because look at this final row. The final row has all positive numbers, and that's great. So when your augmented matrix, we're going to do all these things to it, and when you get to this point where the final row is all positive, you are done. You can stop, and you can find your solution. So you can get the answer from this matrix. How do you get the answer? Well, get the answer. I will show you. So this question, it basically says use this matrix to find the solutions. So remember, for this problem, this is probably x, y, slacker 1, slacker 2, whatever the function was. You could say f or the function, and then here are the constants. So as an answer, we have x equals 1, because there is, x equals 11. We have a 1 here, 1 in the x column. And the 1 corresponds to this one there. That tells us the solution is when x equals 11, because there's 1, 0, 0. That means 1, 11. Y, notice there's a 1, 0, 0. Ah, that tells us that y, the solution is 9. Okay? This one, the slacker variables, which for the most part we don't have to worry too much about, because there's not a 1, 0, 0, they're all positive numbers, that tells us the slacker variable is 0. And again, S2 would also be 0. But here's the big thing you want to look at. This function, 1, 0, 0, it says your function is maximized. So we have a maximum for our function of f at the bottom one, 20. At 20. So your final answer, when you look at this matrix, you can say our maximum is 20. That's why it's in this big bottom box all by itself. We have maximum of 20 when x equals 11 and y equals 9. Again, this is really similar to what you would have done if you'd drawn a bunch of lines and you'd said, well, I want my lines, you found your borders and you had to maximize the function. But if you have a lot of variables, drawing the lines can actually be quite hard, and doing this in a matrix, if you have a computer, is pretty easy. So in the next video, I will show you how to actually do the matrix manipulation to get it from this augmented matrix form, where there's negative numbers down here, into your solution form, where they're all positive numbers.